All right, well, hello. My name's John Muilligan. I will be talking to you today about tabletop game design and how you could work Python into that in an interesting way. So here's the plan. We're going to learn a little bit about solo TTRPGs. Just to show of hands, does anybody know what a solo TTRPG is? Wow, I'm impressed by that. They are definitely growing, becoming more popular. We'll learn what those are. We'll explore how Python can answer some questions about game design. And we'll look at a couple examples from published games. And then at the end, we'll wrap up with a couple tips on when you're designing games, how can Python work into that? Going to cover a lot of stuff. Hopefully there will be time for questions at the end. So who's Exian Press? It's me, that's it. So I started making games in 2021, mostly solo tabletop role-playing games, also some third-party content for a system called Merkborg or Cyborg. If you're familiar with Dungeons & Dragons, Merkborg is kind of a different system, same idea. Done a couple collaborations. Tiny Tome had some things published in there. And I will have a game in Carnegie Mellon Press coming up soon on using tabletop games in the classroom for educational purposes. So that should be coming out soon. And notably, I write at a site called Skeleton Code Machine, and that's where you'll find a lot more about what I'm talking about today. It's kind of how do you use some data visualization stuff to blend that with board game design. So games.exianpress, that's where things are. We'll talk about a couple of these. So what is a solo tabletop role-playing game? So we'll start with Hunting the Beast. So this is one of them. I have an example of what it looks like just as a physical product there. So kind of A5, 30 pages, that kind of thing. And this is a solo game that sort of blends the idea of board games with tabletop role-playing games. Are there any role-playing RPG players in here? Usually some overlap with IT, right? So this has some board game elements as well. So the way it works is it's set in 1700s London. You are a monster hunter, part of a secret society. There's a beast that shows up every 13 years. It's time for it to show up again. Rumors are starting. You're collecting rumors, converting those into wards and weapons you could use for the hunt of the beast at the end. That's kind of the pitch, the idea, right? Mechanically, there's a core game loop that you're going to go through, meaning you start here, you roll some dice, you're going to add rumors to the map. If enough rumors accumulate, the beast shows up and starts hunting you as it moves closer. You could take actions, so you can move from point to point at historic locations in London. You can investigate, where you're drawing cards from a deck of cards that sort of generate prompts and stories as you go. You could verify those and turn them into ways to fight the beast at the end. There's also a journaling aspect like a lot of these have where you're updating your notebook and kind of telling the story as writing prompts. And if you're still alive, you begin the next day and start that over and over again. So it's kind of an example of what a solo RPG might be. So if we look at one of the mechanisms out of that game, there's a bunch of them, but if we look at just one, we'll look at the combat mechanism. So you gain one six-sided die, a D6, every time you get a ward or a weapon. So basically, if you're drawing the clubs and spades out of your deck, you get a learned secret, and you can get up to 5 dice. You roll those dice, you take the lowest single value, a 1 to 2, you win. You've slain the beast. 3 to 4, kind of a draw. 5 to 6, you're taking 2 wounds. Take enough wounds, you die. So that's how the game works. But there's some interesting questions there. So the dice pool goes from 0 dice, where you know you're not going to win, up to 5 dice, and a success on a 1 or 2 only of your lowest one. So there's a lot of questions there that impact player experience. What's the feeling this is going to generate in the end player? So what's the chance of success when you roll a certain number of dice? How many dice do you need before it's actually reasonable? So how fast should you be accumulating those? Should there be a max pool size? Can you just get dice forever? Should it only be on a 1 or a 2, or should it just be on a 1? And how do we cap that chance of success because it becomes less fun if you're guaranteed to win, so we want to stop that somewhere before 100%. So how do we answer some of those questions? So solution one is you just play the game over and over and over again. A lot of designers will say, at least in a full, the games you'll buy at Target, Barnes & Noble, those games, without about 300 plays, you're not really seeing all of what that game is doing. In a simple game like this, it's going to be less than 300 tries, but it's still going to take a lot of time. You don't know if what you're seeing is an edge case because you just happen to roll or not. So it takes a long period of time. Option two is if there's any math people in here, you'll know, well, that's just a probability problem, right? Like I could just do some math, figure out if is it combinations, permutations, which one was it again? I could hit stack exchange and see 4 different solutions to this. It could be a little bit more complicated, and you're not really sure if you got the right answer. So in 2016, I watched this talk, and I can't recommend this one enough. If you are in any job that deals with data, collections, statistics, that kind of stuff, Jake Vanderplas did a talk in PyCon 2016 called Statistics for Hackers. It doesn't sound super interesting, but he basically walks through how you used to do a t-test or do all this math and have p-values and all of that, where now you could just simulate a lot of that stuff. So, you could call it a Monte Carlo simulation if you want to be fancy, but a lot of that you could just do, and then you could visualize the data and get your answer right away. So solution 3 is, well, let's just write some Python and do this. So we could do that really simply, and just for the record, I'm not a professional programmer, so you're welcome to critique. But if we run it once, we could say, okay, so we ran through, we rolled the dice, we grabbed the lowest. In that case, it was success. Sure. So if we roll the shiny math rocks 100,000 times, now we've just shortcut that entire playtesting process. So we know that you're going to have, with 3 dice, a 70% rate of success, 30% rate of failure. But what if I want to limit that to 90%? Where do I cap that dice value? Well, that's pretty easy as well. Now we could just run that across from 1 to 9 dice. Instantly, we know that at 5 dice, we end at about an 86% rate. Now, that's not something you'd show the player at the end, because again, you can make the case that knowing the statistics while you're playing the game actually saps some of the fun out of the game. But from a design standpoint, I now know that they're never going to get more than an 86% chance. So they'll never feel overly confident. There'll always be a little bit of risk at the end of the game. So let's look at a little bit more complicated example. So the risk of being eaten. So one of the other games is called You Are a Muffin. It's a solo journaling game, and unsurprisingly, you're a muffin in a coffee shop or a pastry of some sort. You're watching customers come in, they place their order. Maybe they'll order you, maybe they won't. You slightly become more stale as the hours go by, and then you begin the next hour. That's the game loop. You can tell I wrote that one during the pandemic. So will you be eaten? So this one has, again, just to pull one little mechanism out, it's got a progressive risk mechanism. So it's probably a little hard to see on the screen there, but the hour and risk value. So if the cafe opens up at 6 a.m. and each round you're advancing 1 hour, that risk value is going to gradually go up from 1 to 6. So what that means is you're going to roll 2 dice. If both values are less than that value, then the customer is going to choose you. You're eaten at the end of that round. If either one of the dice are higher than that, you're good for another round. You accumulate some staleness. The game continues. So as an example, it's 10 a.m. You roll 2 dice. You get a 3 and a 6. So you're not going to be eaten that round. Again, this brings up some design questions. How long is the average length of a game? Most people, if they want to do a quick solo game, they want to get away from their phone, they want about an hour, maybe. So you don't want this game to drag on for 6 hours or 4 hours. You don't want that happening even 1 out of 50 times. What are the chances of the game running too short or too early? You also don't want it to end on the first die roll, right? That's not fun. What are the chances of the game running too long? And how should we progress that risk value as each hour goes by? Or should we just have 1 die or 2? How do you answer some of those questions? So again, you could do some quick Python, and you could run through all of those options. You could say, well, what if both are less? What if just one of them is? What if they're equal to or less than? You could do all of those tests. And we know that, well, that first test gives me an average of about 10 rounds, which is what most solo players are going to want. So we could dial that in pretty quickly. Option 3 has the problem that running it that way, it's unlikely, but you could roll 2 1s and the game ends prematurely. So again, using Python lets us do that really quickly. Not that you couldn't do that with some fancy math, not that you couldn't play test it 30, 40 times to sort of see where it's landing, but it's a quick way to get the answer. You can also do some visualizations. So this is after 2,000 times. It also shows, and I'm a big fan of visualizing data, that average is 10, but you could look at the distribution as well and know that, sure, you could get that 4-session game, you could get the 17 one, but it's definitely going to push toward that 10 in the middle. So using a similar mechanism, another one is exclusion zone botanist. In this one, if you've ever seen the movie Annihilation, if anybody's ever seen that one, you're going into a dark and corrupting forest. You are looking for new plants to explore. You're obviously a botanist. And each round, you have a chance of being further corrupted by the forest as things start to go a little weird in a creepy body horror sort of way. You're moving to a new location, and then again, you're beginning the next hour. So just at a high level, that's kind of the core game loop. So again, it's going to be very similar to the You Are a Muffin with rolling 2 dice and seeing where that lands. But in this case, instead of just being eaten, you're going to tick off one more thing on a progression of increasingly creepy sort of mutations that you're going to develop. And you'll have a token and move on that map. So in this one, again, the minimum is 16. You could write some Python to do this very quickly. This is getting a little bit more complicated. Again, you could do math to get this, but now it's not just how many times till it fails. I need that to happen 6 times. So the max is going to be 41. The average is about 24. So this lets you look at the pressure to move in the game, because the whole point is sort of a press your luck. You want to get in, find plants, and get out before it's too late. And you want the player to have a sense of urgency, because otherwise there's no reason to really even play. You could just sit there forever. So you want that pressure, but again, if the underlying statistics aren't necessarily exposed to the player, they feel the pressure, even though in this case, you have probably about 20-some moves, so the chances of completely not getting out are low, but it's definitely some pressure there. So the next one is, we'll look at one more here. And this one gets a little bit more complicated. So this one's called Music in Its Roar. Again, it's a solo one. This was in a sort of anthology magazine. This one I'd say it's hard to even call it a game. It's more of an activity maybe, or a journaling type thing. And it uses what's called a Hexflower game engine, so we'll go over that. And basically, you're starting at number 1 on the hexes. You've come back from a fishing trip, and sort of you're slowly turning into a fish-like creature as you're progressing through this. So you're starting at 1. You're going to roll 2 dice. You're going to take the lower of the 2, and that's going to tell you where to move your token on this map. So if you start at a 1, you roll 2 dice, you get a 2 and a 3, you would move kind of to the northeast there and move up to the 3. So Hexflower game engines are kind of interesting because they allow you to shift states without jumping over things. And that becomes important in like the weather or in terrain, because you don't want to go from where you are in a jungle in one hex and you move to the next one, it's a desert, you move to the next one and it's the Arctic. You want some sort of progression between those. The same with weather. You don't want to have a thunderstorm and then sunny skies and then hot and then cold and then snow. So the way this will work is, in these examples, you would start in the middle and then roll the dice, and you can't really get to a desert without going through something sensible in between. The same with the weather. If you hit an edge, you're going to loop around The way this one's set up, it gives you sort of a push. This one, your dice will push you down and to the left. So it gives you sort of a trend as well. So to look at an example, you'd start at number 1, you roll dice each time, and you will bounce around. In this case, when you hit 19, you will end. So we can model this one in Python too, because I think this one gets a little bit more complicated. If we look at that very first example from 11th Beast, that one's pretty easy. I think even I could do the math on that one to figure out the answer, right? As they get more complicated, I think that math becomes much harder. I think playtesting takes much longer. But in this case, I can write a quick list of lists, map out all the connections that are there. I can now have my list of hexflower directions, and I can easily switch that too. So now I have it set up currently for just 6 faces on a die, but you could easily expand that to 12. And you could try all of those permutations. So what that does is it will do a walk through that for me. So I start at hex 1, I move to 5, 3, 6, 14, I get blocked back to 14, and kind of bounce around until it gives me a route. And it says, well, I got 11 steps to hit that target, and I hit a dead end once. So we can run that 100,000 times, and now we know that you can get there in 4 steps, unlikely. The max, 238 steps, which would be a really bad player experience if you could hit that, but it's very unlikely. The average is going to be around 23 steps. And again, remember Datasaurus says always visualize your data, because this one is a very different distribution than the first one, right? Like the first one had the very nice sort of normal distribution you would expect. This one's all pushed to one side, so it will help you understand what that player is likely to see. So some things to think about. Number 1, you don't need to be good at writing code. I'm not a professional programmer. I can write some Python. It's functional. But I think, and that's one of the things I wanted to stress, is there's probably more elegant solutions to the way some of these code things were done. Absolutely. The other thing is I'm not making them modular or extensible, so it's not like I write a generic class for dice and a generic class for hex flowers, and then I could reuse those components. Pretty much I'm doing this from the ground up each time because they're almost throwaway code at that point, right? And that's okay. You don't need to be good at it. Focusing on the rules and components versus elegance and efficiency sometimes makes sense. It reduces errors, and it actually, you could step through, like I'm going to model rolling the dice. I'm going to model when a player chooses the lowest each time. And if you can model it completely, I would question how much player agency actually exists as well. The thing to know here is that you can model tiny little mechanisms, right? Like rolling the dice and what's the chance of success at this many dice. But anytime you get into complicated things, certainly in role-playing games where you can allow for creative solutions, or you can get into complicated board games where the decision space is huge, right? You could select multiple cards, you can get points in multiple ways. That becomes a much harder problem to solve with simulation. So I would be hesitant to say you're simulating full games 100,000 times and getting them perfectly balanced that way. Because if you have a method of combat, and you can look at this in like role-playing games where I have a sword, I'm gonna attack the goblin, I swing at the goblin, I miss. It swings at me, it hits and I lose 2 hit points. I swing at it, I hit and it loses 1 hit point. And you go back and forth. In that example, if you didn't have other options, there's no player agency there. There's no choice, there's no control. You're just kind of on autopilot till somebody dies. So that would be a case where from a design standpoint, I'd say, take a look at it. So modeling, great for the little bits, probably not for the player experience. Visualizing your data, I didn't include anything in this one about pandas and seaborn. The charts that you saw today I actually just threw in Excel kind of dump the data to a CSV and bring it in that way. But some of the other things I've done, it makes sense to get a kernel density estimate or kind of overlap those. And pandas and seaborn, again, I guess how many people have used pandas significantly or at all? Anyone? Okay. So I guess that's a way of building up data frames, and seaborn is a way of making those visualizations look nice and pretty. So it has a lot of built-in chart types. So that is definitely a way to go, and it makes it easy to visualize that data. And then the last thing is, this doesn't actually replace playtesting with humans. I think Python has huge amounts of potential. Even though some of the examples that I showed here, I think you'd say, well, yeah, that's obvious. Of course you could do that. I think in the tabletop game design world, it's a lot less common. This is a new scenario where people are looking at this and seeing it in a different way. Where, hey, I could quickly test this and maybe tweak it, and it's just this little part of the game, but it just saved me 30 hours of playtesting time. Or I could tweak this little bit over here, and sure, it wasn't a hard question, but I just saved myself 3 hours of testing on that. That starts to add up over time. But at the end of the day, you can't replace the human in this. They're going to play it, and how does it actually feel at the end of it? So I think the big takeaway is this allows you to iterate faster. So it doesn't change the design process overall. But at the end of the day, you're taking out the bits that could be a little boring, that could be a little routine, sort of the grind of like, I don't want to queue up 4 playtesters to play the hex flower a bunch of times just to know how many steps it takes to get through there on average. That's kind of a waste of a playtester's time at that point and my time. When I could write some Python, simulate that quickly, and now tweak it so when it does go to those playtesters at the end, they're getting the best experience, and it's actually worth their time to playtest as well. And that is it. Definitely left a little time for questions here. So again, if you're looking for anything, Exian Press is me and the games. The one at the bottom there, Skeleton Code Machine, I've done a bunch of interviews with other people who are using Python in their development. So it's definitely becoming more common. It's not super common, but absolutely. And a little bit more on like data science and running some simulations on games, like Merkborg running some basic like, hey, if we had a character fight a skeleton 100,000 times, what does that tell us? Or in character creation, we have all of these different classes. Can we actually see, are they balanced? Do they make sense? We could simulate generating characters, 100,000 times, and then see visually how do those character classes stack up. Again, it's sort of adjacent to human playtesting, but I think some of that can be really interesting, and it doesn't take a lot of Python knowledge to make it happen. All right, so that is it. We have time for questions if anybody has any. What's that? Oh, yeah. Oh, thank you.
Folks, any questions for John?
Anything? Okay, there we go.
So what other, do you know other games, you mentioned other designers use Python and other stuff to simulate playtesting, anything we would have heard of?
I know that Cole Worley, who makes games like Root, if you've heard of that one, Pax Pamir, some of those games, they're actively using, I can't say they're using Python, but they're actively using simulations to be able to check some of the components in that. I think they're actually going another step further, where it's not just doing quick math, but absolutely, yeah. So that's probably the most notable example I would be able to say off the top of my head. Any other questions? Anyone? Oh, yeah.
How long does it take you to code a test? And usually for a single game, how many tests do you make? And then how many hours of testing do you think that probably saves you?
Yeah, it's a good question. For the examples I showed, they're pretty simple. So I don't know. It'd be hard to put time to it. An evening, maybe, whatever that time period means. And there'll be a couple tests. The examples I showed were mostly about like how long that game end state will take. So I'm trying to think, but it would probably be about one, maybe, test per game. But as far as time, like I said, I think some of those early examples saves me an hour or two. I'm not super clear on how I'd get to an answer on a thing like a Hexflower game engine quickly without that. I think that would take a lot of time because it's now a much more complicated problem, right? You're sort of working through a network versus just like rolling dice and is it high or low. So in that case, I think it would save hours and hours and hours of time. And I think when you're stepping anything beyond this into the sort of like whirligig games, leader games like Root and those kind of games, those simulations are saving them vast amounts of hours as well. And again, it's the time saving, but also getting, when you're handing it to a play tester, I think they're getting a better product to play test as well. So that's a good question. Anybody else? Oh, is there one? I have lights in my eyes, so I may not see you. Sorry. There you go. I think what really shows up is how bad the edge cases could be, because it's easy to look at averages, and certainly if you are playtesting manually, like, well, it's a solo game, I'm just going to play it 10 times, right? The chances are you're just going to end up somewhere in the middle of that distribution. But what really shows up when you start doing this a large number of times, and I'm sort of doing 100,000 just because it's free, right? Like, it doesn't matter what that large number is. Honestly, past about 300, it starts to level out. But I think it's seeing those edge cases. Like, oh my goodness, that Hexflower game engine could go 240 some turns, right? Like, that would be awful. Like, that's a bad player experience at that point. So now you can work backward from that and say, well, how likely is that? Do I want to tolerate that at all? The same on the other end. It's like, well, you can't have it end on the first turn. That's a scenario I don't want to allow at all. So I think being able to see those edge cases at the end is something that wouldn't show up with just normal human play testing. Yeah, that's good. Thanks. Oh, one back there.
Do you have to, when you're designing games, how much does that take to impact the game itself? Do you try to eliminate those edge cases, mitigate them?
Yeah, absolutely.
Or you just say, well, it's 1%, I'm not worried about it?
Yeah, I think it depends on the type of game. And like some of the examples I showed here, like obviously having a game end on turn 1 and that happens 10% of the time, to me would be unacceptable, right? Like 1 out of 10 times is just unacceptable. If it is like that Hexflower game engine where it's more of an activity, it doesn't need to be a balanced game, it's gonna attract a different kind of person. If you have a 1 in 10,000 chance of something happening, if overall I think it's gonna be good, I think that's all right. But I think it depends on the type of game. And when you move into board games, that's a whole different story, right? Because now people expect to have balance. They expect to have no king making. Like, there are certain expectations in board games that attract a competitive player, right? Now edge cases matter a lot. Where in RPGs, honestly, if it's a GM, you could fudge it a little bit. If you're a solo player, you can hand wave it. There's more tolerance to handle that. So I guess that's where it ends up, is like, what kind of player experience are you trying to generate, and how much tolerance to that is that player type going to have? So, yeah.
Does Python offer a specific utility that other programming languages don't?
No. So if the question is, well, why are you using Python and not Ruby or any of the other 10,000 things? There's no reason. I happen to personally like Python. It's the one that clicked for me, and that's what I have the most experience with. But yeah, I guess you could have done this exact talk with like using Ruby to accelerate tabletop development. It would have been just as good. I have a friend who uses Dart, which is a language I'm not, is anybody familiar with that at all? It's a different one, and some of them are a little bit easier to make mobile apps for and things like that. But there's nothing magic about Python other than I tend to like it. Yeah, that's a good question, though. I should have made that more clear. Yep. Yeah.
So the
Yeah, I think it goes back to sort of if you can model it completely in Python, it means it's okay to have as like a tiny mechanism in the game, but it means that little bit doesn't have a lot of player agency. So at my coding level, I've been doing fairly simple things. I think you could do a lot of stuff with like card decks. If anybody ever play like Pandemic or one of those board games, that's usually pretty popular. So that does something where you're stacking the deck up front, where you have those the epidemic cards or whatever they are. They're kind of evenly spaced throughout the deck. So this, you can model that pretty easily. I'm trying to think of one that I had wanted to do but wasn't able to. It's been very binary for me up to this point. Or it's either yes, I can do it, or you're looking at full-blown complicated games, and I'm not even attempting that. Yeah. I think there are other probably better simulation tools out there when you're getting into like full board game simulations. Like I said, there are design companies absolutely doing that. I think it's in a distinct minority at this point, though. And I think it just has a huge amount of potential where not everybody's using it. Yeah? Yeah, right there.
That particular example, is there wraparound? Looks like the 2 can go to the 11.
Yeah, so it probably, you can't see it too clearly here. Yeah, so like the way you would read this is, let's say you're at the 6. So you have a token on the 6 right now, and you roll a 4, so you'd kind of go southeast. That would wrap around to the 14, and then some of them are blocks. And if we go back to, again, the Hexflower game engine is not mine. That's the website that is credited as the originator of this. But yeah, you could put different loops in, and that's the other thing that changes it. So you can start to tweak that as well. That's one of the other variables that once you get it mapped out as a hex map, well, that's just changing 1 or 2 numbers and see if I got rid of all the loops, how does that impact it? If it loops infinitely, how does that impact it? I think that's where the code makes it easy, because once you have that framework, well, now you're making tiny little tweaks, rerun it, and it gives you your answer. So if I didn't want an average of 23 steps, and I don't want this to go more than 10 steps, you could quickly iterate that, get it to 10 steps before you ever hand it to a human. Yeah, that's a good question. Anybody else? Oh, I think there's one back there. Yeah, so I think the Hexflower one is really interesting, right? Because it's away from the normal probability stuff. So that one's the most interesting. Honestly, because You Are a Muffin, as ridiculous of a game as that is, that was the first time because I was trying to figure out, like, how do I lay this out? Because I don't want it going too long. That's when I was like, hey, wait a minute, that Jake Vanderplas talk from 2016 had some good ideas in it. What if I just started to simulate this? So that's the one that really like changed it for me. I was like, wait a minute, this is a valid way to go, and I'm not sitting here rolling dice manually trying to figure it out. So that's the one that sticks out for me. Yeah. Anybody else? Questions? Those are good questions so far. All right. Okay, thank you.